So now that you've learned a little bit about the history of soap as well as the risks associated with it, we will be telling you guys about the saponification process, which is essentially the process where soap is created from a fat or oil in a strong lye solution.
Soap is made up of two components. Typically, fat, which can come from plants or animal products. As you can see in the video, olive oil is being used. The second component is a strong lye solution, which makes up the hydrophobic part of soap, so it can dissolve greases, oils, and fats.
So once the two components are combined, a chemical reaction starts to take place, which is known as the hydrolysis of esters or saponification. So the two reactants here are a triglyceride, which is a fat or an oil. The triglyceride component of soap is an ester, as you can see from the double bond O and the oxygen. The second component is a strong lye solution, which is typically sodium hydroxide or potassium hydroxide. Sodium hydroxide is used to make hard bar soap, while potassium hydroxide is used to make liquid soap.
The saponification reaction is basically a reaction in which the ester is heated in the presence of a base. When the triglycerides in a fat or oil react with aqueous sodium hydroxide and potassium hydroxide, they are converted into a soap and a glycerol.
And the products formed in the hydrolysis reaction are glycerol in the form of an alcohol and a soap molecule in the form of a carboxylic acid salt. The glycerin that is produced as a byproduct in the reaction can either be used in the soap as a humectant to attract moisture to the skin, or it can be removed from the soap and used for other purposes.
The basic structure of all soaps is essentially the same, consisting of a long, hydrophobic, water-fearing hydrocarbon tail and a hydrophilic, water-loving, anionic head.
The length of the hydrocarbon chain varies with the type of fat or oil, but is usually quite long.
Nearly all compounds fall into one of the two categories: hydrophobic, which is water-hating, and hydrophilic, which is water-loving. Oil and anything that will mix with oil are hydrophobic and non-polar. Hydrophilic and hydrophobic compounds just don't mix.
So the water molecules are very tightly packed, whereas the oil molecules are larger and far apart, which is why they do not mix.
As you can see in the products formed by saponification, the hydrocarbon fatty portion dissolves dirt and oils, while the ionic end makes it soluble in water. Therefore, it allows water to remove normally insoluble matter by emulsification.
Soaps are useful for cleaning because soap molecules attach readily to both nonpolar molecules such as grease or oil and polar molecules such as water. Although grease will normally adhere to our skin or clothing, the soap molecules has a hydrophobic tail which can make it easier to rinse away.
The soap molecules help water get a hold of the grease, break it up, and wash it away with its structure.